Welcome to this explainer, where we're going to dive deep into the life of Albert Einstein. We're going to completely deconstruct that cultural caricature we all know, the wacky, absent-minded genius, and instead reveal the truly multifaceted theoretical physicist and morally conflicted human being behind the famous equations. We'll break down exactly how one man completely rewired our fundamental understanding of reality and how his legacy extends way, way beyond the chalkboard.
So, here's our roadmap for today. We'll be looking at 1. The 1905 miracle year, 2. His 1921 Nobel Prize, 3. E equals mc squared and the 1939 letter, 4. The unified field theory, and finally, 5. His activism and global legacy.
All right, let's jump right into Section 1, the 1905 miracle year.
We begin our story in the Swiss Patent Office in Bern. What's truly staggering here is the sheer density of a 26-year-old clerk's output during what became known as his Annus Mirabilis, his miracle year. In between refining other people's patents at his day job, he kept what he jokingly called a physics department in his bottom desk drawer. And from that very drawer came 4 world-changing papers, all published in a single year. It's absolutely wild to think about.
The real standout here is special relativity. Einstein realized that the speed of light is an absolute constant, and he took that absolute limit way more seriously than anyone else alive at the time. By doing so, he proved that space and time aren't these separate, fixed stages where the universe just kind of plays out. They're actually interwoven into a single, flexible continuum called spacetime. So what does this all mean for us? It means time literally ticks differently depending on how fast you're moving. It fundamentally shattered our classical Newtonian understanding of reality.
Moving right along to Section 2, 1921, the Nobel Prize.
Let's see how his career builds from there, because there's actually a fascinating twist. His worldwide validation and his Nobel Prize weren't actually awarded for his famous theories of relativity. At the time, relativity was still considered highly debatable. Instead, he was recognized for the photoelectric effect. See, in the 1800s, science viewed light purely as a continuous wave that slowly accumulated energy. But Einstein proved that light actually behaves as an individual particle, a quanta. Think of it like a tiny basketball hitting a surface and immediately dislodging particles upon impact, rather than just washing over it like a wave.
So the crucial takeaway here is that this specific revolutionary discovery regarding the wave-particle duality of light is what officially earned him the 1921 Nobel Prize in Physics. He provided the very first clear connection between theory and observation that light can act as a particle, and that laid the absolute vital groundwork for the entire evolution of quantum theory. A total game changer.
Now we arrive at Section 3, E equals mc squared and the 1939 letter.
As we move into the late 1930s, the stakes of his theoretical physics violently shifted from pure academic curiosity to geopolitical warfare. The world was on the brink of conflict. So let's address the elephant in the room, a really pervasive cultural misconception. Did this lifelong, outspoken pacifist actually build the weapon of mass destruction used in World War II?
To really understand his true role, we have to look back at the 4th paper of his miracle year. In it, he famously provided this devastatingly simple equation, E equals mc squared. It mathematically proved that energy and mass aren't just related, they're literally different ways to measure the exact same thing. Mass is essentially just a super concentrated form of energy, and that specific insight laid the theoretical foundation for nuclear fission.
Now, why is this so explosive? Well, because c, the speed of light, is a massive number on its own. When you square it, it becomes astronomically enormous. Because of that multiplier, a tiny discrepancy in mass when an atom is split releases an earth-shattering amount of energy. To put that into perspective, just 1 single kilogram of matter contains the energy equivalent of over 40 megatons of TNT. However, his actual physical involvement with the bomb itself was virtually non-existent. In 1939, terrified that Nazi Germany would harness nuclear fission first, he signed a letter urging President Roosevelt to research uranium. But when the Manhattan Project actually began, the U.S. Army Intelligence Office flat out denied him a security clearance due to his left-leaning political views and his well-known pacifism. He was never even at Los Alamos. Yet, the cultural association stuck, and it tormented him. This quote starkly highlights his profound moral crisis. It perfectly captures the heavy human regret of a pacifist who, out of fear of a greater evil, inadvertently laid the theoretical and political foundation for the atomic age.
Let's shift gears to Section 4, the unified field theory.
We now transition to the latter half of his life, which was essentially consumed by a relentless quest that most of his scientific peers considered a tragic, fruitless waste of his fading genius. See, he simply could not accept this massive disconnect in physics. He had given the world general relativity to explain the macro, stuff like gravity and curved spacetime, but the micro world was governed by electromagnetism and quantum mechanics. The universe seemed to be speaking two completely disconnected mathematical languages, and for 30 years he tried to unite them.
One of his collaborators described this period as groping in the gloom of a mathematical jungle. Unlike his earlier breakthroughs that relied on his brilliant physical intuition, here he was operating almost entirely in the dark. And though he ultimately failed to find this unified field theory, he boldly established unification as a respectable, deeply serious scientific objective for future generations.
Finally, we reach Section 5, Activism and Global Legacy.
We have to look at his transition from a theoretical physicist to a global symbol of intellect, because his impact certainly didn't stop at the edges of the chalkboard. Practically every facet of modern technology reverberates from that 1905 miracle year. The GPS tracking systems in your phone, they actually have to adjust for his relativity just to work properly? And the digital cameras we use every single day trace right back to his photoelectric effect?
But his legacy extends far beyond mere physics and technology. Impartially reporting on the historical sources we have, Einstein was also a highly vocal activist. He openly favored socialism over capitalism, firmly advocated for a world government and global law, and actively fought against racial injustice. He notably volunteered as a character witness for civil rights leader W.E.B. Du Bois and co-chaired the American crusade to end lynching with Paul Robeson.
He also viewed the political inquisitions during the Cold War as a direct, existential threat to academic freedom. As this quote illustrates, he fearlessly used his unparalleled worldwide fame to defend those persecuted during the McCarthy-era Red Scare, believing that suppressing unorthodox thought was incredibly dangerous to a free society.
As we wrap up this explainer, we look at the absolute monumental shadow he left behind. Today, thousands of string theorists and quantum physicists are still wandering through that exact same mathematical jungle he entered a century ago. So we're left to wonder, will his ultimate vision of a single, elegant theory of everything, a truly unified, deterministic universe, ever actually be realized? Thanks for exploring the mind of Albert Einstein with us.